Let's look at an example of a perfectly elastic collision. Two particles below of mass 2 kilograms and 4 kilograms are going to undergo an elastic collision in one dimension. The velocities are 1 meter per second to the right and 1 meter per second to the left. If they rebound off of each other in a perfectly elastic way, what will be the final velocities of these particles? In what direction will they be going? To solve this, we need to take two principles into consideration. Momentum must be conserved. Not only that, but also kinetic energy is also conserved. Those are the two things that we need for an elastic collision. Alright, so to write that symbolically, the sum of the initial momentum has to equal the sum of the final momentum. And the sum of the initial kinetic energy has to equal the sum of the final kinetic energy. So let's label each of these balls A and B. I'm going to write the mass of A times its velocity of 1 meter per second plus the mass of B times its velocity of negative 1 meter per second. That's going to be a way to express the initial momentum of the system. That needs to equal the final momentum. But instead of using V here, I'm just going to call it big A. A stands for the final velocity of the ball A. And B stands for the final velocity of ball B. What I want to do is I want to just plug in the numbers where I can. So we'll get 2 times 1 plus 4 times negative 1 equals 2A plus 4B. And we can further simplify that to 2 minus 4, which is negative 2, equals 2A plus 4B. And that's as far as I can go with that equation. I can't solve an equation of two unknowns with just one equation. So I have to involve another equation. I've got to involve the kinetic energy. So I'm going to move over here. And let's go ahead and write the kinetic energy equation. It's going to be 1/2 ma times 1 meter per second squared. This is just the kinetic energy formula for both balls. Okay, now I have to use that's the initial. Now we need the final. Okay, I'll plug in the actual masses of the objects. Okay, I'll do this on calculator here. Simplify a little more. Okay. Now we have our two equations. I'll write them here side by side. When you have two equations and two unknowns, the problem is solvable. You just have to go to an online system of equations solver. Let's go to symbolab.com. And this is an online equation solver. And it does systems of equations too. So now you just want to type in the equations that you have. Put a semicolon between them. And then hit go. Okay, what the program is giving us here is two possible sets of solutions. In one of the sets, you'll see the original velocities that the objects had. That's the 1 and the -1. That's pre-collision. But if we look at the other solution, -5/3 and 1/3, that will be the post-collision velocities of the objects. So that's going to be our final answers. So V final for A will be -5/3 meters per second, which is approximately 1.67. Okay, and then our final velocity for B will be +1/3. It's approximately 0.33 meters per second. So after the collision, the small ball will have rebounded with a higher speed than it came in at. And the large ball will rebound also, but at a slow speed. So in this collision, both momentum and kinetic energy are conserved.